Hello guys and welcome to another video. On this video we'll be looking at how to go about finding the limiting reagent, or you could say limiting reactant. But before we do that, let's look into the definition of limiting reactant or reagent. So guys, the definition of limiting reagent or reactant is the reactant which is completely, or that is completely used up in a chemical reaction. And from that we can also look into another definition, which is the definition of excess reactant. And excess reactant would be the reactant that is not completely used up in a chemical reaction. Those are the things that we need to know in terms of the definitions of limiting and excess reactants. Now coming to our activity, here we see that we have 160 centimeter cubed of a 1,5 mole per dm cubed nitric acid solution, which reacts with 15 grams of calcium carbonate according to the following balanced reaction. This is our balanced reaction. Now, before I get into our question, I want you to be aware that when dealing with these type of questions, one of the things you need to ensure is that your equation is balanced. Okay, in this case we are told that we have a balanced reaction. Okay, so we don't have to balance this, but you can always double check. We won't do that for now because I do trust that this one is balanced accordingly. Now let's get into our question. The first one says here, identify the limiting reactant. The limiting reactant, like the definition states, is the one that will be used up completely, and that means that it has to have less number of moles basically. Okay, and there's quite a process that we need to follow in terms of us going about finding this limiting reactant. But the first thing that we need to do is to look at the information we have. When I go through my information, this is what I noticed, that I'm given 160 centimeter cubed of what? Of a 1,5 mole per dm cubed nitric acid. Okay, where is my nitric acid here? This is my nitric acid. So I'm given the volume of nitric acid and the concentration of nitric acid. Then the second thing I see that I'm given is this mass. This mass belongs to what? It belongs to calcium carbonate. Where is calcium carbonate? This is calcium carbonate. Okay, so those are the things that I have. All right, I have the volume of nitric acid and its concentration, and I have the mass of calcium carbonate. So for me to solve this problem of identifying my limiting reactant, the first thing I'm going to do is to use this information that I have to find the number of moles of these two substances. Okay, and I'm going to do that by using formulas in this case. How do I do that? Well, I will start with my first step. My first step is to find the number of moles of I'll see HNO3 and CaCO3. So I'm going to find the number of moles of these two. Okay, I'll start with nitric acid. So I'll say for nitric acid, which is HNO3, this is how I'm going to go about doing that. I'll say for nitric acid, I see I'm given the volume, which I have to convert first. So if I convert this volume, it's going to be V is equal to, because it's in centimeter cubed, I want it to be in decimeter cubed. So I will take the 160 and I will divide it by 1,000. If I do that, the answer I'm going to get is 0,16 dm cubed. So that's my volume when converted to decimeter cubed. Then from there, I will use the formula that has the information I have. I'm given volume, I'm also given concentration. And what am I looking for? The number of moles. So here I will say that C is equal to N over V. This is my formula to find the number of moles when I have concentration and volume. My concentration is 1,5 is equal to the number of moles I do not know, and my volume is this one that I just converted, which is 0,16, and then from there I'll do a cross multiplication, this times that and this times that. So when I say n times 1, I get n is equal to, and then I'll say 1,5 times 0,16. I'll have to use my calculator for that. Okay, so when I say 1,5 times 0,16, the answer I get is 0,24 moles. Okay, this is my number of moles for nitric acid. Then after that, I'm going to find the number of moles of calcium carbonate. But when I check calcium carbonate, I realize that I'm given the mass of calcium carbonate. And because I'm looking for the number of moles of calcium carbonate, I have to think of the formula that I will use, which will help me to find the number of moles of calcium carbonate. And that formula is going to be as follows. So I'll say for CaCO3. To find my number of moles for calcium carbonate, I'll say that I'm going to use N is equal to mass over molar mass. All right. Excuse me. Then from there, I will check what is the mass of calcium carbonate. It's 15 grams. So I'll put 15 here. Then I'll divide by the molar mass of calcium carbonate. I can always find it here. Let's find it here on the side. The molar mass of calcium carbonate, CO3. Okay, hope you can see that. The molar mass of calcium carbonate will be as follows. We'll use our periodic table. I need to show the periodic table for this one. All right, so yeah, for us to find the molar mass of calcium carbonate, what we are going to do is use our periodic table. So we'll look at the molar mass of calcium, and the molar mass of carbon, and the molar mass of oxygen, and we'll add all of those molar masses together. Okay, so when I look at the molar mass of calcium on the periodic table, here's my periodic table. Here's calcium. The molar mass of carbon is this number here at the bottom. Let me just highlight it. This number here at the bottom, because we see here relative atomic mass, that's the molar mass, the number here at the bottom. Okay, so we'll take this number and put it here. So the molar mass of calcium is 40, and that of carbon is 12. Where's carbon? Here is carbon, and we see that the molar mass of carbon is 12. So I'll put it here, 40 plus 12 plus oxygen. In terms of oxygen, I see a number at the bottom, and this number tells me that I have 3 atoms of carbon. So I'm going to take this 3 and multiply it by the molar mass of oxygen, because I have 3 oxygens. So here I will put 3 and then open a bracket, go to my periodic table, and there's my molar mass of oxygen. It's 16. So I'm going to put 16 here. Okay. Then from there, the calculator will do the rest of the work. So I'll say 40 plus 12 plus 3 in brackets 16. Close my bracket and press my equals sign. And the answer I get here is 100 grams per mole. This value is my molar mass. So where I see this big M, I know that the big M represents molar mass. So I will put here 100 for my molar mass. Then I will say 15 divided by 100. And when I say 15 divided by 100, what do I get? I get 0,15 moles. Okay, I should say mole and not moles. Mole. Okay. Once I have this now, guys, I'm going to go on to my second step. Okay, what is going to be my second step? Well, my second step will be to use ratios And what am I going to use ratios for? I will use ratios to find the number of moles of these two substances that I need, okay, that I need to end up forming my product, okay. So that's the machine that I'm gonna do now. So let me just scroll. So the way in which I'm gonna do that is to say, can just draw a column there that separates these things like that. So what I'm gonna do is to use ratios now to find the number of moles of this substance and this one, okay. And I will list those substances as ratios. So I'll say nitric acid is to calcium carbonate. Then after writing down these two substances, what I'm gonna do is look at the coefficients of the two substances, which will give me my ratios. And I see that the coefficient of nitric acid is 2, so I'll put it here, say 2 is 2, and the coefficient of calcium carbonate is 1, so I'll put 1 here, okay. So I'll say 2 is to 1, and then after writing the ratio, I will now write the number of moles of these two substances. Let's say I want the number of the number of moles of nitric acid. Because I don't know that answer at the moment, I'll just put N here. Then I'll say is to this side, I will put the number of moles of calcium carbonate which I found in the first step. So the first step was this one here. That means I will say 0.15. And then from here, I will do my math. Say n multiplied by 1 and I get n. Then I will say 2 multiplied by 0.15 and I think my answer should be 0.13. 0.30. Let me just confirm. 2 times 0.15 is 0.3. So my answer here will be 0.3 more. Remember that here I'm looking for the number of moles of these two substances, this one and this one, using what? Ratios. Where am I getting these ratios? From the coefficients of these two substances. That's why it's important for me to balance my equation correctly. The coefficient of nitric acid on the equation is 2, so I put it there, and then the coefficient of calcium carbonate is 1. We know if there's no number here, it means there's a 1. There it is. And then from there, what do? I solve for my number of moles. But before I do that, I need to ask myself, what's the number of moles of this one? I don't know it at the moment in terms of ratios. This one, I will use the ratios that I got this up here, okay, on the first step. Then from there, what do? Cross multiplication. Because I'm looking for n, I will say n times 1 and I get n. Then I'll say 2 times 0.15 and what do I get? 0.3. That's my number of moles for nitric acid. And then I come this side. This side, I will do the same thing of listing my substances as ratios. So I'll say HNO3 is to CaCO3. And then after here, what do? Put down my ratios as they are, or coefficients. So it's 2 is to 1. But this time, I'm looking for the number of moles of calcium carbonate. So it means I have the number of moles of nitric acid, which are these ones that I found here. See these ones. So here I will put 0.24 is to the number of moles of this one, which I do not know. And then from there, it's cross multiplication, meaning I will say 2 times n and I will get 2n is equal to 0.24 times 1 will give me 0.24. And then from here, because I'm solving for n, I will divide by 2 on both sides. So my n will be equal to 0.12 mole. Okay, after this step, guys, this is what I'm going to do. I will take, let me change my color here just for you to see what I'm talking about properly. So after this step, what I'm going to do is to take these number of moles, okay, and these are the number of moles I need. The ones I found using ratios are the ones I need so that my product can be formed, basically. Okay, so what I'm going to do is to take this answer that I got here and subtract it from this one that I got in the first step. Okay, so I can say, to make it look easy, I can say the number of moles of nitric acid is equal to, okay, I will say 0.24 minus 0.3. You don't have to write this down. You can use a calculator to get your answer. So what I will say is 0.24 minus 0.3, and the answer I get is a negative 0.06. Okay, I'll explain what we do with this information afterwards. Let's now look for the number of moles of this one by taking this value and subtracting it from this one here. So here I will say the number of moles of calcium carbonate is equal to this answer here, 0.15 minus 0.12. So when I say 0.15 minus 0.12, the value I get is 0.03. From here, I'm going to compare now this and that. When I check which one between these two is less, well, the one that's negative is definitely lesser than this one that is positive. And now what does that tell me? It tells me that nitric acid is our limiting reagent. Why? Because it's less. I mean, it's negative. It means I'm short of it. So it's limiting. Okay, my spelling there. So nitric acid in this case will be my limiting reagent, and this one will be my excess. Okay, this one will be my excess, the calcium carbonate. So I can conclude that therefore the number of moles of nitric acid that I have are less than the number of moles that I need. Therefore, nitric acid is our limiting reagent. Yeah, the spelling there, guys, or reactant. And yeah, that's how you pretty much answer 2.1. Okay, the first step is to find the number of moles of the two substances using the information given. For nitric acid, we were given its concentration and volume, so we substitute into this concentration formula to get that. This side, we were given the mass of calcium carbonate, so we use the N is equal to mass over molar mass formula. Then from there we substitute, then find our number of moles of calcium carbonate. After that, we find the number of moles of the two substances using ratios. And then after we find those values, what we are going to do is find our limiting reagent using what? Using the subtraction of what we found here from what we found in the first step. So we take the number of moles we found using ratios and subtract them from the number of moles we got using formulas. And yeah, that's pretty much it in terms of 2.1. Now we'll look into 2.2. Okay, finding the mass of water. Guys, gonna erase this, but I believe that if you want to get this, you will just pause the video and then write everything down or rewind, whatever that works for you. Okay, for 2.2 they say what mass of water is produced. Okay, and now for us to answer this question, we will start by finding the number of moles of water. Okay, we'll find the number of moles of water. How are we going to do that? We will use ratios. Okay, and the information that we make use of is that of the ratio of our limiting reagent, which we found to be the nitric acid, and then this one. So for 2.2, what we'll say is that the ratio of nitric acid, which is HNO3, is to H2O, and then we'll look at the coefficients of the two, and we see that the coefficients here are going to be 2:1, right? Okay, let me just fix that. Here it's supposed to be a 1. So here I will have 2:1 in terms of my ratio taken from the coefficients of the two substances that are nitric acid and H2O. Okay, then from there I will look at what I have in terms of nitric acid. Obviously, I know the number of moles of nitric acid. I found them in 2.1 using the volume and concentration of nitric acid, and I found those number of moles to be 0.24. I hope you remember this. Then for hydrogen, I obviously don't know the number of moles of hydrogen, thus I will use ratios to find them. How am I going to find them? I will say 2 multiplied by n, and I should get 2n, and then 0.24 times 1 will give me what is it going to give me? It's going to give me 0.24. Okay, before I proceed, I want to let you know why is it that I'm using this nitric acid and not calcium carbonate. The reason is because nitric acid is my limiting reagent, meaning that it's the one that will get used up in order for me to end up having my products. Okay, this one will be used, but just a little bit, meaning that it will remain. All right, most of it will remain, hence it's an excess reactant. But this one that's limiting is the one that will do the work so that I end up having my product. I hope you understand that. That's why we choose to work with the nitric acid here and not calcium carbonate. Now, when I proceed here, I will divide by 2 because I'm trying to do what? I'm trying to solve for n. And if I solve for n here and I divide 0.24 by 2, the answer I get is 0.12. From here, I will say, okay, now I finally have the number of moles of water, and I'm looking for what? I'm looking for its mass. All right. In this case, the original problem says I must find its mass. And for me to find its mass, the formula we'll use is n is equal to small m over big M. My n in this case, let's move to here. My n in this case is 0.12 is equal to, my m is what I'm looking for, the molar mass of water. I mean the mass of water, my bad. And I will divide that mass by the molar mass of water. For me to get the molar mass of water, I will say, okay, I have 2 hydrogens, and the mass of hydrogen is 1 plus the mass of this oxygen here, which is 16. That means I'm getting 18 here. So the mass of water will be the number of moles multiplied by the molar mass. The number of moles is 0.12, and the molar mass is this one here. When I say 2 times 1, I get 2. 2 plus 16 will be 18. And then I'll multiply these two values together. So I'm going to say 0.12 multiplied by 18, and the value I get is this value correct? I don't think so. Okay, the value I get, it is correct. The value I get is 2.16 grams. So this is the mass of water basically. Okay, hope this makes sense. We'll do another problem in the next video. Please don't forget to like the video and subscribe. Okay, see you on the next one.